All right, so it's been a long, busy day, and this is the only time I've got to record it. So I'm recording this not quite in the middle of the night, but it's pretty late. So let's show you the way that different mollusks build their shells. And this is going to be generally true of mollusks that have shells. Remember, there's those two groups that do not have shells, the solenogastries and the caudofoveata. Yeah, but all the rest of them do. So here we go. First, let's draw some little pictures of each of these groups, just so we have them. So we're going to have, let's make sure we can see it. Yeah, we can see it. Okay. So we're going to have our tusk shells up here, and they're going to have a little critter that comes out of them. And so these are scaphopods. And then we're going to have our monoplacophora, which have one shell. Mono, and we're going to have the polyplacophora that have an 8-part shell. 2, 3, 4, 5, 6, 7, 8, and they have kind of a skirt that runs around the edge, about like that. So these are poly, and they're both placophora. So monoplacophora, polyplacophora. Fantastic. All right, let's switch up. We need different colors from next groups, because why not? Let's do our bivalvia. So we'll have a little bivalve. We'll draw a scallop on here. And so they're going to look something like that. And so these are bivalvia. And bivalve means they have two valves. That's B-I-V-A-L-V-I-A. Bivalvia. And next to those, let's put our snails. So we'll draw a super generic looking snail. There we go. And so snails are in the gastropods. So gastropoda, which means stomach foot. Yeah, which is a kind of a weird name to give anything. Then we've got our, let's do it over here. We've got our cephalopods. So let's draw a squid. And their eyes are something like that. And so here, we'll draw the little tentacles coming out. Rah. And then they're going to have two long hunting tentacles that come out here like that. There we go. And we'll draw a little bit of that little ruffly bit going back, but we'll just assume that we know the rest of it is there. And so these are going to be cephalopoda. There we go, cephalopoda. And then the last two groups that we're covering are going to be these solenogastries and the caudofoveata. And the names are printed out in the presentation. You can look them up there. And these are both going to be shell-less, and they look like little sort of fluffy worms. They're very similar looking on the outside. I will show you that one of them tends to have plates and the other tends to have bristles, but you know, you can find examples that have either of those things. So now, as far as, all right, let's make our little shell. Let's build a seashell. So you gotta have a bottom layer, and the bottom layer, remember, is going to be beta chitin. And so the mollusk is going to lay down that layer of beta chitin first. And then on top of the beta chitin, it's going to put in these little molecules. Let's drop a couple of these little proteins down here. And each of these is called PIF80. There we go. And PIF80 is going to attract calcium carbonate around it. It's going to hold on to calcium carbonate. And so we're going to build a little calcium carbonate plate around each one of these things. About like that. So the job of PIF80 is just to sort of get the crystal started, be like a little crystal seed. And so this is going to be our calcium carbonate in the form of aragonite. Aragonite form. because that's what oysters make, and that's the one that's actually been studied in detail. And then remember, we're going to have something over the top, and so let's make sure we make a nice little net over the top out of all of our, there we go, our sort of bendy, wiggly, twisty shematrin. And again, it's spelled out very nicely in the talk, but there's our shematrin proteins. And so that's one layer. And usually with mollusks, once per year, they will put down a new layer. So when the temperature is just right, like for example in the spring or summertime, that's when they're going to grow. And it's all lined up with when they have their babies. They do things at different times, so they're not constantly growing. But yeah, they'll put on a new layer of this, and then when they're ready to grow again, yeah, let's move our shematrin over here. Shematrin. Then bam, they'll put down another layer of beta-chitin, and they'll put down some more PIF80s, and they'll put down some more calcium carbonate, and it'll be joined up as a ragonite because of the PIF80s. They force it into that form. And then over the top, we'll lay another layer of shematrin, just like so. Just like that. And so, yeah, that's, and the older they get, the thicker and larger the shell is going to get. They'll just keep growing a little bit at a time. And you can actually use these things like you would use tree rings to kind of date a fossil, and you can read out a record of the climate, which is kind of neat. When there's a really warm year, more of this calcite dissolves into the water, and so they can put on a thicker layer before they actually get the shematrin over the top to cover it up. And so, yeah, you got a little climate record there inside these shells. There we go. All right, thank you.